Hello friends, welcome to my channel, and in this video we are going to see how to develop a simple Spring Boot application, and we will also see that how we can connect our application with a database, and we'll do some database operations. To understand this video, there are basically two basic prerequisites. First one, you must have the basic knowledge of Java programming, and the second one is the conceptual knowledge of object-oriented programming, because we are going to touch few of them, but I'm not going to deep dive into these concepts in this video. So I'm going to use Visual Studio Code. You can use whatever IDE you prefer, but if you are planning to code along with me, then I would suggest you to use Visual Studio Code. To create Java application or Spring Boot application using Visual Studio Code, I would recommend you to install at least these two extension packs. First one is Java extension pack. This one is from Microsoft, and the second one is Spring Boot extension pack. This one is from Pivotal. Okay, these extension packs are basically provide some extension which enables you to simplify your development process. Okay, so because Visual Studio Code is a lightweight IDE and it doesn't come with pre-installed bundles, so we need to install and configure our Visual Studio environment according to our language that we are planning to use. Okay, so this particular extension comes with Spring Initializer, the same that we usually use to create a project here, spring.io. Okay, here when we go to this section, quick start section, it provides some tool to create our project. Okay, the same kind of thing we can do here with the support of this extension. It enables us to create a project. Okay, and this is for debugging, and it gives the all tooling that you can use to debug your project. Okay, so let's create our project. To create a Spring Boot project in Visual Studio Code, you just have to press F1, or you can use this shortcut command, Control plus Shift plus P. Okay, so just press F1, and now you need to type Spring Init. The moment you type Spring Init, it will come up with few options, and from that we need to select this one, create a Maven project. Okay, now we need to specify the version of Spring Boot. I'm going to use the latest stable version, which is this one, 2.4.2. okay, now we need to specify the language, Java of course, the group ID for our project, I'm going to say LSIO, and the artifact ID is going to be Spring Boot. Now we need to specify the packaging type. This is required when you want to deploy your project on any web server. Okay, so I'm going to use Tomcat, and I prefer this one, WAR. Okay, now we need to specify the version of Java. I'm going to use 1.8. You can use either 1.8 or any later version. Now we need to choose some dependencies for our project. This project is going to be a Spring Boot RESTful application. So for now I'm going to select Spring Web. We will need other extensions also to make connectivity with database, but that we will do later on. Okay, so for now just this one, press enter, and I'm going to generate this project inside my F drive. Now I got the message, click on open, and this is our project. Okay, say yes, and we are good to go. Okay, you can see in our pom.xml the initializer that we used to create our project, it already added this extension automatically, and these two dependencies that you see here, is this one is for test, and this one is an embedded Tomcat server to run our application. Okay, so the beauty of Spring Boot initializer is the moment you generate your project, it is always ready to run. You can check this by navigating to this folder and this file and just go to run and say run without debugging. Wait for a few seconds and you will see that your server is running on port 8080 or whichever port is free on your system. Okay, now we can check our application here, and of course we are not going to get any output and we will get 404 instead because we haven't configured any route yet. Okay, so let's do that first. I'm going to create a folder inside Spring Boot, okay, and I'm going to name it controllers. Okay, and inside this folder I'm going to create a file home controller.java. Okay, for this tutorial I'm going to put all my endpoints in this class only, and we need to tell Spring Boot that we are going to use this class as a controller which is going to serve one or more endpoints. Okay, to do that we need to annotate this class with REST controller because our application is a RESTful web application, so the type of controller should be REST controller. Okay, now let's specify our first endpoint. To do that, just write a function. Let's say hello, and I'm going to return as simply hello say user. Okay, now we need to annotate this function with some kind of HTTP request. Okay, like we have request get, post, or put or delete. Okay, so I'm going to map it with get, and for that we need to annotate this class with get mapping and open a parenthesis. Now inside this parenthesis we need to specify our endpoint. So what endpoint this function is going to serve. Okay, so whenever user type say hello in the URL, this function should trigger and should serve the request. So let's check this. Run our project and our server is running now, and let's say hello. Okay, so hello user. So we are getting the message. This is a really simple implementation of a REST controller. Actually we are doing nothing here, just returning a plain string. But in real-world application we implement REST controllers in a such way that we receive the request from the user on any endpoint with maybe some data and delegate that request to microservices which may be running on the same server or maybe on external servers. Or we can delegate that request to business logic which is written within the application, which actually handles the request, processes the data, and returns the response back to the REST controller and then way back to the user. So this is the typical structure of a medium scale application, and in our next chapter when we see that how we can connect our application with the database, let's try to implement one of these. To do that we need to do some configurations in our application so that we can access the database server. The first step that we need to do is to add a dependency in a pom.xml file. I'm using PostgreSQL version 13, so I need to add a driver dependency here which is suitable for my version of PGSQL. Okay, if you are using any different version, you need to find out the correct version for your database server. So now I'm going to add it manually so that we can learn how we can add dependencies manually in our pom.xml file. Let's go to Maven repository google.co.in, type maven postgresql.org and go to this link. I found out that this one 42.2 is suitable for PGSQL 13, so I'm going to use this one and add it here. Just save it. Now it is added. In next step, we need to add one more dependency in our application, and for that go to pom.xml file, and here we need to add the dependency for Spring Data. We can add it either manually or we can ask Spring Initializer to do that for us. This time let's go to the Spring Initializer and add it from there. Just type add starters. Oh, by the way, press F1 to come to this window. Click on add starters and here type JPA. This dependency is actually a bundle of Java Persistence API and the ORM Spring Data and Hibernate, okay, which enables our application to store and retrieve the data from the database, right? Just press enter, proceed, and dependency is added. So now in next step, the final step of configuration, we need to go to this file, application.properties file, which is under resources folder, and here we need to write some configuration and rules that Spring Data will use to access the database and form the CRUD operations, okay? And first we need to specify the URL to our database and the username and password. For that, just type datasource.url, which is jdbc, PostgreSQL, then localhost 5432 and the name of the database, Spring Boot. Now datasource.username Postgres, datasource.password. Now datasource.driver class name org.PostgreSQL driver. Now Spring JPA.showSQL, say true. We need to see whatever SQL query is executing in a console, and say test while idle, say true. And now validation query, which is select one. Now we need to specify the naming strategy, implicit naming strategy first. It should be implicit naming strategy. Which one? Oh, this one, legacy, not this one. This one, right? Now the next one is physical naming strategy, okay? So here Spring physical naming strategy. So this is it. We are done with the configuration part. Now let's move to the next part, which is creating a table in a database. So let's move to our database and create a table. I have already created this database Spring Boot, and inside this I'm going to create a table, cities. First column is going to be our primary key, city ID. Then it should be serial. I want it to be generate automatically, not null primary key. Then city name, and here character varying should be under 30 characters, not null. Save it. Now let's add some data and try to access this data from our application. Delhi, New York. This is it for now, and let's move to our application and access this data from any of our endpoint. To do that, we need to create an entity bean for our city table with the same schema structure, so that the Spring data can make use of that bean to access and update the data in the city table, right? For that, I'm going to create a folder inside Spring Boot entities, and inside this folder city.java. Like we did in our REST controller class, like we annotated this class with @REST controller, so that the Spring will know that this particular class is actually a controller and going to hold some endpoints. The same thing we need to do with our entity class as well, but here we need to annotate this class with @entity, right? Now the next thing that we need to do is map the table with this class. So we need to map the table with this particular city class, and for that we need to annotate this class with @table, and here we need to specify the name of the table, which is cities, right? So whenever we access this class, it is actually going to access our cities table. Now we need to specify the columns which is in our table, like city ID and city name. The city ID is auto-generated one, and it is a primary key, okay, and it is using this sequence. So we need to specify this here in our entity class. So how to do that? The first thing we need to do is annotate this particular column with @ID, okay, and which column we are going to target with this local variable, okay. So inside this we need to specify the name of the column. Since we have specified the name of the column here, our local variable name could be anything, okay, and we can say like ID. So whenever we access this particular field, ID field, it is going to refer to this one, okay. Now this one is all good. Now we need to specify the generation type, because whenever we insert the data, this particular column should generate it automatically, the value of this column, okay. So for that we need to specify the generation type for this column. We are using PostgreSQL, so in PostgreSQL we need to use the identity generation type. So how to do that? Here we need to say generated value, or inside this we need to use the strategy, what strategy it should use to generate the next value in the sequence, which is generation type dot identity, right? So this is done for our first field. Now our second field in a database is city name, okay. So let's say private string, it is a character type, character varying, the data type of that field is. So here we need to say string and city name, and this field is going to refer to this column, column name city name, right? Okay, now we need to generate the getter setter for these two variables, and for that you need to go here, source action, generate getter setters, and select all, okay, right? So this is it. This is the schema for our table, and we are going to use it to access and update the data. But just hold on, just writing this entity class doesn't mean that now we can access the data. To do that, we need to create few more files. So let's do that. Inside Spring Boot, I'm going to create a folder, repositories, and inside this I'm going to create an interface class which is city repository.java. Now this is not a class, this is going to be an interface and extends JPA repository. Okay, and this is going to handle the city entity. The primary key type is long, right? For now, just leave it as it is, and let's create a service class which has all the functions to access data from our city table. We can do this directly from here also, but like I said, that we don't do all heavy lifting in controller itself. Instead, we just delegate the request to other business logic to perform that operation and to handle that request, right? So here just specify one more get mapping, and this is going to be like get cities and public, which is going to return the city type object. Okay, and the function name is get cities. Now return. Now we need to tell what to return here. Okay, that we will do now. So let's create one more folder, again services. Here we are going to put all our services here, and city service dot java. Okay, we need to annotate this class with service so that Spring will know that this is actually a service class, and it would always available for AutoWire in the context. Okay, and likewise we need to annotate this class as well at the rate repository. The same thing, the moment we annotate this class as repository, it will available for AutoWire in application context. Okay, now city service here and home controller here. Like I said, just AutoWire our repository class, AutoWire city repository as city repository, this one. Now create a constructor city service. Okay, now let's create our function to get cities from the table. Public list of city list of city get cities, and here we are going to return city repository dot find all. This is the default function that we have to access all data whatsoever in that particular table. Okay, so this function is going to fetch all the data from the city table and return it as a list of city class, right? Now here we just need to say @AutoWire city service, and from here we need to say city service dot get cities. Okay, now let's access this one. Oops, return, and this should be list of cities because we are returning list of cities from there, right? So let's run our application. Okay, our application is running. Just go here and say get cities here. So we have seen how we can access the data from the table, right? Let's see how exactly things are going. Okay, the user hits this endpoint first, get cities, and since we have auto wired this service, and since we like annotated this class at the red service, what Spring does whenever we compile our application, it creates an instance of this service class and make it available in the application context so that we can auto wire it, right? So this city service class is already instantiated by Spring Boot, and we are just using that instance to access this function of city service class. So now what this function is exactly doing, in this city service class we have did the same, like we auto wired this time city repository from the context. Okay, since we annotated this class with @repository, Spring made it available for us. Okay, now we don't need to initialize this, so we can directly access whatever function this repository has. By default, the JPA repository has some inbuilt function, and the find all function is one of them, right? What find all function returns is, it returns the list of city. In city class, the each instance of class holds a single record of our table, right? So by saying this find all, it is going to simply return all the rows in our table in the form of list, right? So we are getting list of city by calling this function, and we are returning this directly to our controller, and from controller we are returning this to user, like we have seen in this particular example here, this one. Okay, we are like sending requests to our business logic within application, and we are getting the response, and the same response we are forwarding to user, right? So this is how our program is working now. Now in the next section we will see that how we can insert a new data in our table. So let's create one more endpoint which basically accepts the data in the form of the object of city class, and we use that data to update our table, our city table. Okay, so let's create one more mapping, post mapping this time, because I'm going to submit some data. Endpoint is going to be add city, public void save city. Okay, let's say I'm going to return the same city object that user is supplying, but this time with updated value. Okay, we will see that how we can do that. City, and here we will use the same city service to save the data, like save city, and we will pass the object which user has passed with the request. Okay, this method is not there yet, so let's create it, this one, and here now we can simply say city repository dot save, okay, and pass this object which user has passed, right? So this is also an inbuilt function. Okay, in JPA repository, what it does, it just accepts the object of the bean and save the record in our database, save or update. It does both. Okay, we don't need to like write different function for save and different function for update. If the ID field is greater than 0, then it will perform update, otherwise it will create a new row in our table. Okay, let's say it is going to return the city, and just return it, and by default this function returns the object of the bean class, and but this time with the updated value. Okay, so this function is going to return the city object to the controller, and the controller is going to return the same object back to the user. Okay, so now let's check this. This time I'm going to use the Postman client. This is a really useful application to check your endpoints. Okay, so this is it, and now we need to say I'm going to submit the post request to my endpoint localhost 8080. Then the endpoint is add city, but this time we need to supply the body parameter, which is going to be a JSON data. Okay, in JSON data we need to provide the key and value pair, right? And the key parameter should be the same name of this variable. Okay, so I'm going to say ID. Then we are going to create a new row in the table. So we say ID equal to 0, and the second parameter is city name, which is this one, and here we say Toronto. Okay, now let's submit the data. Here it is. Let's check our database, refresh it. This is our data. Okay, now let's fetch the data from the Postman client using this endpoint, get cities, create a new request, this time get request, and this one get cities. See, we got the data. Now we can update the data using this same endpoint, and to do that, let's say the ID of Toronto is 3. This time instead of 0 we need to pass 3, right? So we are going to update this entry. Okay, so this time let's say Toronto city and just send this. The name is updated. Check this here. Here it is. Okay, so this is how we access database using Spring Boot application. And so far we have seen that how we can fetch all records from our table and how we can insert a new record or update any existing record, right? Now let's create one more endpoint, which is for searching. This time user is going to pass a city name along with the request, and we are going to use that city name to search our table. And by this mean we will make use of this repository as well. Let's see how to do that. I'm going to use get mapping this time and get city, the singular one, and public city. I'm going to return the city if found, get city, and expecting the user to pass the city name. If found, just return city service dot get city, and we are going to pass the same city name that user has passed, right? Now create this function, and here we need to say city repository dot find by city name. You can use find by anything which is here. If like there is one more property here like city code, you can simply say find by city code, but the first letter of the variable should be capitalized. Okay, here city name C is small, but here it is in capitals, right? Now we need to define the same function in our repository. Okay, so let's create this function. Okay, we need to pass the city name as well. Okay, and here we need to simply say return city if find by city name returns any data. Here city name. Okay, now we have defined, all is good. Let's check once. User sent the request with city name, and here we are using city service get city function. We are passing the city name, then this function is calling this function. It's basically implementing this function and passing this city name which has been passed by the user. Okay, let's check it. This time we are going to hit this endpoint with city name. Okay, let's access this endpoint. Get city, and in request data we need to send a form data, and city name should be like, let's search this one, Toronto City. Send. Here it is. So this is how we can perform the search operation using Spring JPA repository. So we have seen all three operations. Okay, one more thing I want to tell you here, that in terminal you can see that the Spring data is showing all the SQL that it is executing in background, and if you want to debug, if in case any query fails during execution, you can directly copy this query and you can try executing this query in your database query console here. Now here you can remove the where condition, or you can just pass anything that you are trying. Like in our case, we were trying Toronto City, and you can check your query by this way. Okay, so this is it for this video. I'm going to come up with more advanced Spring Boot concepts in my future video, and if you don't want to miss any notification regarding my new videos, then hit that subscribe button, and please hit that like button if you like this video. Okay, thanks for watching. Bye bye and take care.